All right, so we are starting chapter 3.1, which is Intro to Graphing. So our first assignment here is to circle what's wrong with graph A and then properly label them in graph B. So first, let's talk about the quadrants. Are the quadrants labeled properly here? No, right? They are not. Okay, so where would quadrant 1 be? Would it be in top right, top left, or bottom right? Where's quadrant 1? Okay, we're not looking at AI or anything like that. All right, so we're getting some conflicting answers. Some saying top right, some saying top left. Okay, so it should be top right. Okay, so quadrant 1 should be top right. So I would label this quadrant 1. Okay, and then where does quadrant 2 go then? Does it go top left, bottom right? Which way? Where is quadrant 2? Not top right. Where's quadrant 2? Top left. Good. Okay. So quadrant 2 is top left. What about quadrant 3? Is it bottom left, bottom right? Quadrant 3. Got a 50-50 chance. Good. Bottom left. Okay. So 1, 2, 3 goes down here, and then number 4 goes down here. Okay, this is essential, especially when you get to trigonometry. Okay. Because the x-axis, right, will start here on the right side of 0 degrees and it goes counterclockwise, okay, when you're measuring the angles in a unit circle. But anyway, it's beyond what we're talking about right now, but it's essential that we go this direction, so counterclockwise when we number the quadrants, okay? All right, so what about quadrant 1? What kind of points do we have for quadrant 1? Are they positive, negative? What are they? What kind of points do we have for quadrant 1? Good, right? They're both positive. So this is positive, okay? All right. So what about quadrant 2? What's that going to be? What do we have for quadrant 2? Good. Negative, positive, right? So this is negative, positive. Good. What about quadrant 3? Both negative. Perfect. Okay. It's kind of like someone sleeping. All right, how about quadrant 4? Good. Positive, negative. Perfect. Okay. All right, so let's talk about our axes here. Okay, where's the x-axis? Is it horizontal or vertical? Horizontal, right? So this is our x-axis, so that means then our y-axis is here, right? Right? Is the origin located here? It's in the center, right? So let's put O for origin, okay? All right, so that's our origin here. So far we should have circled the x-axis, the y-axis, that's not right. All the quadrants are not correct, right? Okay. And now, now that's also labeled this. So this is an ordered pair, right? This is called an ordered pair. All right. So you have your x coordinate and then your y coordinate. Okay. So x, y, and then you have x, y. Okay. All right. Now how about the coordinates themselves on graph A? Are any of them correct? Are any of the coordinates correct? No, right? All of them are wrong. So you should have circled every single one of these things. Okay? They're all wrong. Okay? So that's properly labeled then. So 4, 3. So I have 1, 2, 3, 4. Right here's 4. And then 1, 2, 3. So here's 3. So 4, 3 is right there. Okay. And then I have 6, 5. That's not where it is. 4, 5, 6, 3, 4, 5. So 6, 5 is right here. Okay. And then where's 0, -4? Where's this going to be? Where's 0, -4? What's that at? Where would that be? Where is that located? X-axis towards the left. No. Down 4 from the middle. Good, right? So 0, -4, right? So if we have 0, -4, okay? So 0, that means this is our x coordinate, and then this is our y coordinate. So our x coordinate, right? X coordinate is the ones going left to right, right? So 0, so we stay at the origin, and then the y says, okay, that's where it goes up and down. And it says we need to go down -4. So -1, -2, -3, -4. So 0, -4 is right here. Okay. All right. And then we have -4, -3. 1, 2, 3, 4. I'm sorry. 1, 2, 3, 4. 1, 2, 3. Right. So here's 0. -4, -3. And then the last one is -4 and 6. So -4 and 6 is up here. All right, so this is -4, 6. All right. All right, so again, this section is very short. It's just the basics of graphing. So understanding this is a coordinate plane, your X and Y axis, sometimes called the Cartesian plane. Okay. Knowing where the quadrants are and understanding in each quadrant what, if what kind of numbers you have there, either they're positive, negative, so on and so forth. Okay. So understanding the relationship and plotting this relationship. Okay, so I already mentioned about the ordered pair, right? So this is the x and y coordinate. All right, and it has the form xy. So these are all examples of an ordered pair. We just talked about the rectangular system, okay? How it goes counterclockwise, starting at the top right as quadrant 1, and then going counterclockwise to quadrant number 4. Okay. Um, Scatter plot. So I'm sure you've heard of scatter plot before, and the purpose of a scatter plot is to determine whether there is a relationship between two items or two things. Okay. So does shoe size, does that determine your math ability? So the bigger shoe size you have, does it mean you're better mathematics? I don't know. Okay. Maybe that's a study you can do. All right. So they're trying to see if there is a relationship with them. All right. So whether there's a positive relationship, a negative relationship, whether that relationship is really strong or really weak. Okay. So scatter plot actually leads into um, linear regression or line of best fit, things like that. All right. So the data there gets really, really interesting and fascinating, actually. Okay. All right, so basically you get have a set of points here and you just plot them, and that's what a scatter plot is. And then you try to see if there's a relationship between the two areas that you're trying to compare. Okay. Then you have a line graph. Okay, so basically this is an example of a line graph. Okay, so just two drawing between two consecutive data points. Okay. All right, so let's look at a word problem here. It says infant mortality. The line graph shows the U.S. infant mortality rate for selected years. A, comment on any trends in the data. B, estimate the infant mortality rate in 1990. And C, estimate the percent change in the infant mortality rate from 1970 to 2010. See if we can figure that out. Okay, so in this topic here, a question says the line graph shows the U.S. infant mortality rate for selected years. Okay, and this is from 1970 to 2010. And that's in the years part, and then mortality rate is per 1,000 birds. All right, so as we look at these questions, before we look at the questions, we want to analyze what's happening with the data. It looks like it's declining, right? Throughout the years, it looks like it's declining. Okay, so we're talking about the infant mortality rate. All right. So part A says comment on any trends in the data. Well, as we can see, the infant mortality rate is decreasing. Okay, so hopefully you wrote that down for part A. It's decreasing. Okay. Part B, estimate the infant mortality rate in 1990. Well, here's 1990, right? And this is the data we're looking at. All right, so it's close to 10, so it's probably 9, right, on there. So the infant mortality rate in 1990 would be 9, okay? Again, that's per 1,000 birds. All right, and then the last one here, estimate the percent change in the infant mortality rate from 1970 to 2010. So let me pause that here. Okay, yes, as noted, the process of finding the percent change, okay, is the new minus the old divided by the old, and make sure the new minus the olds is in parentheses, okay? That tells us we need to do that first. And then whatever we get our result here, then we multiply by 100 to get the percent change, okay? So we're looking at two particular years, or the percent change from 1970 to 2010. So we're looking at the y-axis, right? Because we're looking at the percent or the rate, okay? So in 2010, all right, it looks like it's just above 5. The mortality rate is 5, so probably about 6, okay? All right. From 1970, the looks like the mortality rate for that one is 20. Okay, so 20 is the mortality rate. So, um, so in this case, our new value is 6, right? Because that's more recent, 2010. So this would be 2010 minus 1970 data divided by the 1970 data. So in 2010, okay, we got 6 minus 1970 data, that was 20. Okay, and then divided by the 1970 data. Okay, all right, so 6 minus 20 is negative 14. So we get negative 14 on the top, and then divided by 20, and then multiply that by 100. Okay, so negative 14 divided by 20 is going to give us negative 0.7, and then multiplied by 100 will give us negative 70%. Say about negative 70%. Okay, so those are our answers for this problem.